Hey guys, welcome to another video. So today, another nice question in the nice question series. Today's question comes from the Extension 1 syllabus from the North Sydney Girls 2022 trial paper. Now, last question in the test, 8 marks comprising of 4 parts. It's a really nice question. And now the topic that it relates to is actually a mix of topics, right? It's got functions, so a bit of advanced curve sketching in there, where we use addition of ordinates. And then it sort of slowly merges into a rate of change question. So really nice question, I think, for us to explore today. So before I dive in, if you haven't already done so, please subscribe to the channel, like the video, and tell your friends. All right, guys, let's get stuck in. So, all right, let me zoom out just to so ignore the bit on the right with the response sheet because you sort of need it for part 1. So let's have a read. So North Sydney Girls, and firstly goes the graph. Okay, that's the graph. Is shown on the separate sheet, right? So response sheet, I'll show you the graph in a sec. On the response sheet, what I need to do, use addition of ordinates, right? To try to sketch now. That looks exactly the same as the original, but you can see there's an extra element of, and I'll highlight it now, of x squared, right? So they've added x squared onto the original, you know? So between the y limits of 10 and negative 10, okay. You do not need to find the x coordinates of the endpoints. Okay. Part 2, show that you can rearrange it out. Okay, that looks pretty easy. Now part 3, you know what? Part 3, I'll get into it later. Basically, it's a volumes question, right? So a bit of everything. There's curve sketching, there's calculate volumes, and also then there's rates of change, right? I'll get into that maybe later. So maybe for now, let's sketch and rearrange first. So what do they want me to do? So this graph here, original, is what they tell me. This graph is, I'll use black. This is y equals to -1 on x squared, right? So for me to sketch y equals to x squared minus 1x squared, right? So basically that's adding on this element. So it makes sense then for me to sketch maybe in a different color. I'll use blue maybe. Y equals x squared. So just a parallel 1. Now that's 1 and that's 1. So okay, that's 1, 1, 2, 4, and then 3, 9. And then 1, 1, 2, 4, -3, 9. Okay, nice symmetricals. Okay, it's very hard to draw this with a digital pen, but let's see. Okay, it's pretty good. Okay. You know what? This is as good as it's going to get. Beautiful. Yeah, so now I need to add my ordinates, right? That's how they want me to do this. So let's have a look. So at the origin, it looks like there's an asymptote. So I might draw an asymptote here. Yeah. How should I draw it? No, what I'll do, I'll just stop my line here. Is that okay? Yeah, so I've got an asymptote coming downwards. Yeah. And then, okay, let's see, add ordinate. So that looks like it's -1 plus 1, that's 0. Same with that point there. Looks like, well, it's symmetrical, right? Clearly symmetrical. Now, if I know that that's probably like what, a small negative fraction adding onto there, so slightly below here. Now, guys, this is the pattern, right? See how these guys here get small, the fractions get small and small negative? It's like adding those small negatives onto the blue line, right? So in a sense that the x-axis becomes the asymptote, this blue line becomes the asymptote, right? So it sort of looks like, you sort of go add a little fraction onto there, right? So I'm expecting something to look along the lines of something like sort of using the blue line as a guide, right, for the asymptote. So something like that right now. Yeah. Sorry, not straight. So yeah, something like that. Now, what happens down here? Let's have a look, right? So it looks like the blues now, it's the blues' turn, right, to add little fractions onto the black, right? So I'm expecting then the black to become the asymptote down here. So, like for example, adding there would be a little fraction on top of that. This guy here will be, so yeah, something along the lines of that. Now, I'm going to see if I can do the same on the other side. So add little fractions onto here. Right, so looking like that. Oops, coming down here. Really hard to draw with digital pen here. And so it comes down something like that. Yeah, so my green graph there, maybe I'll label it. Oops. Maybe I'll label it like this. There, get rid of that circle. And then I'll label the blue as Y. X squared. Okay. Guys, so the green graph is really what I'm interested in, right? Actually, it tells me between 10 and negative 10. So actually, instead of putting arrows in there, right, which is technically not correct, what I will do is to give me a point. Right? They actually want me to do it, right? So they want me to go all the way and go up to. No, they don't care about the y, so the x intercept. So I'll just go that, go all the way down here, maybe put a point. Yeah. So negative 10 to 10. Okay, perfect. Guys, that's my answer. Yeah, for part one. Now, what's part two want? They just want me to take gx and then make x squared the subject. Okay. So so this is obviously for part one. Part two, if x squared minus 1 on x squared, what am I doing? Equals to y, right? So y equals that. Now, feels like I'm going to common denominator it. X4 minus 1. It's like solving a quadratic, right? Times that up. So yx squared equals to x4 minus 1. So bring the yx squared over. Treat y like a constant for now. And I'm going to solve this quadratic, right? So then, therefore, x squared equals to minus b plus minus b squared minus 4ac all over 2 times a y plus minus square root y squared minus 4 over 2. Therefore, is that what I want? We have a quick look. Well, oh, that's a plus, yeah. And because it's x squared, right? There's no plus minus needed, right? Since x has to be. Now let's think about it, right? Since y squared plus 4 is bigger than y, I can't have a minus because then the square root of that is negative, right? So it'll be the plus version only. And I'll put in brackets the reasoning for that, right? So 2 reasons for that, because one, root y squared plus 4 is greater than y. So I can't have a minus, and therefore, and also x is, or x squared rather, is always greater than or equal to 0. Yeah, that's my answer. Guys, how's that? Right, first 2 parts, not too bad, hopefully, right? So just adding ordinates to get that graph, and then just a bit of algebra to get part 2. Now, part 3 is where it's at. Let's see. I'm going to take my time. I'll go to the next slide. Actually, I might need to borrow this graph. I think I'm going to stay with this. Maybe I'll do this, right? Maybe I'll move everything up here for a bit. And then maybe I'll move this down here for a sec. Yeah, that'll work. Okay, let's look at part 3. Okay. Now, let's take our time here, right? So a glass with a hollow stem with base at negative 10 is made by rotating the part of gx where x is positive and y is between that, about the y-axis. Okay, so rotating part of the, yeah, okay. Now, going back to my graph, this is what they want. They want, when x is greater than 0, they want this arm here, right? And they're going to rotate that, right? They want to rotate that about the y-axis. They want to rotate here. And if you can imagine, once you rotate, you sort of get like a flute, right? Like a cone, actually. You know, like those funnels that you filter out paper, like a funnel. Yeah. So we're going to rotate it about here. So it's going to basically create like, you know, that sort of shape, right? So get like a funnel shape, right? Okay, yeah, just picture that. All right, cool. Write down a definite integral, which when evaluated will give you the volume. Okay, I can do that. Write down a definite integral. So just integrating the volume of x, yeah? X squared, pi x squared, yeah? Okay. Oh, do not attempt to evaluate this. Good, because I think it would be fairly hard. Okay. And then now part 4, liquid is poured in. Okay. Liquid is poured into the glass, right? That's created by the volume upstairs at this, right? So I won't do that yet. That's a fact. All right. Let me see. Yeah. Now, and then it goes, find the rate at which the surface of the liquid is rising, right? So when it is 6 centimeters from the top of the glass. 6 centimeters. Okay, that's interesting. So let me do part 3 first, and then I'll deal with that volume question, rate of change question in a sec, right? So part 3 basically says, okay, I need a volume for this guy, right? Now I know volume is normally equal to pi between A and B. Now, because I'm spinning it about the y-axis, it'll be x squared dy, right? Yeah. In this case, the x squared, which is why they got me to do part 2, right? The x squared is that, right? It is that. Yeah, because I'm dealing with only the positive version, it is just that, right? So I'm going to sub that into the integral, and I think that's it, right? I think that's it. And then the two limits, right? Just to be absolutely clear, two limits are that's minus from minus 10 to 10, right? Yeah, and this guy here is the expression downstairs. So therefore, volume will just equal to pi minus 10 to 10. Or was it y plus minus? Oh, not plus minus, it was just plus, right? Square root of y squared plus 4y, oh, plus 4 all over 2 dy. Now let me just look at that downstairs. Yep, I think that's it. Let me just check that. Yep, perfect. Guys, that's my answer. It's only one mark, all right? There's only one mark. All right. Now let me try to do the next bit now. Now, the next bit is cool, right? Rate of change with this story, all right? Part 1, part 3 in mind. So what do they want? Basically, they're saying that liquid is coming out, is it? Or poured in. Liquid is poured in, right? So that to me feels like a dV dt equals to 1.5 centimeters cubed per second, right? And it's asking me to find the rate of change that the liquid is rising. So it's changing y, right? So the question here is dy, find dy dt, right? Equals the question mark. When it's 6 centimeters from the top. Now, this is important. 6 centimeters from the top. If you think about what that means is that 6 centimeters, if this is 10, right? That's the top. 6 centimeters is about there, right? This is 6, right? So that means sub in when y equals to positive 4, right? Yeah. So at that point, y equals to 4. So let me come back down here. In terms of this integration and rates of change question, by giving you 6 centimeters from the top, that's basically saying when y equals 4. That's hard, right? That's hard. So I need normally when I do this, I state the volume formula in terms of some other variable, right? In terms of y, state the volume in terms of y, differentiate it, and then sub in the 4 and sub in my dV dt, and I get it, right? So let's see how I can get that. Now, the volume of this thing, right, is a weird shape, but this is the thing. They gave me the volume formula from part 3, right? So let me just copy that. Yeah, so just copy that formula from part 3, right? Delete that. And we start there, right? So normally if you like, let's say for example, when it's a sphere, it's for the volume equals to 4 to 3 pi r cubed. And if it's a cylinder, it's pi r squared h. This one here, volume is an integral, right? So what I would normally do at this stage, right? The moment I write down the volume normally, I'll differentiate both sides with respect to time, right? So just to be clear, yeah. So this whole expression here, right? This whole expression from here to here, that's just an expression, right? Yeah. And then, so just to be clear then this guy here, that's just a function of y, right? That's just like function of y. Yeah, just keep that in mind. Because then when I do this, right, if I have like dv dt, right, that'll normally, if I applied the chain rule to this, right, dv dt will be like dv dt, and then I'll insert dy's in there, right? dy, dy. Now, the question has this as a thing that I need to find, question mark. The question has this as a thing that's given to be, is it 1.5? 1.5. I now need to find the expression for this, right? dv dt. Now, I know, so dv dy, I know that the integral, right? The integral of this function, right? This function here is dy is the thing that's the volume, right? dv dy would be the thing inside, right? Because if you think about it, right? Okay, let's see if this makes sense, right? If I come back up a step here, yeah. So I get rid of this concept here. Yeah, actually, let me go down a step. If I wanted to, so this bit here, I need to get the pink. So I've got the blue circle is 1.5. The green is what I'm trying to find. I need to find an expression for the pink, right? A volume currently equals to this. So if I differentiate this with respect to y, right? Yeah, that's like basically differentiating. So I put the pi here. D dy. So dy dy. dv dy. Right the way. dv dy. Yeah. dv dy in this case, so dv dy in this case, remove the v here. It'll be the derivative of this integral from -10 to 10 of y plus root y squared plus 4 all over 2 dy. Right? Obviously then, mathematically, the dy sort of cancel out. What am I trying to say? You're differentiating an integral. Guys, what happens when you differentiate an integral? They sort of mutually cancel out, right? And the thing that's left over, that is your function. Yeah, that is your function. So what am I trying to say? Therefore, continually move this down. Therefore, the expression for dy, so dv dy, is pi multiplied by this function itself, right? So y plus root, yeah, y squared plus 4 all over 2, right? That's the thing that needs to be populated into here. Yeah, and then I sub in my y equals to, was it 4 downstairs to get my final rate of change. Wow. Okay, let me say that again, right? Because normally, when we have a rate of change question with volumes, they'll give you a volume equals to 4 pi r cubed. You differentiate the v, the v dt, and on the other side, you apply the chain rule and you get dr, sorry, you get dv dr, and then dr dt. And then dv dr is just differentiating the expression. This one here, differentiating the expression, you actually differentiate an integral, which means you don't actually need to do any differentiation. You just take the function itself and you plug it in. Wow, that's nice, right? That's nice. So then what you're going to get is like 1.5 equals to pi multiplied by y plus square root y squared plus 4 all over 2 times dy dt, which is what I want. And then remember the last piece, right, is that you got to sub in y is 4, right, from the question itself, right? From the question itself. So then you get like 1.5 equals to pi 4 plus, what's that, 16, so root 20, yeah, on 2 times dy dx. Let's be amazing, right? Let's simplify root 20 to, what's that, 2 root 5. Not that it matters, right? I just feel like it's nice just for us to then clean up the 2, the 4 to like 2, right? So then divide that over, and you get therefore dy dx as an exact value, right? Will be 1.5 pi 4 all over 2 times dy dx. And then remember the last piece, right, is that you got to sub in y is 4, right? From the question itself. So then you get like 1.5 equals to pi 4 plus square root y squared plus 4 all over 2 times dy dx. And then divide that over, and you get therefore dy dx as an exact value, right? Will be 1.5 all over pi multiplied by 2 plus root 5. Yeah. Let me punch this in the calculator, see if I can get it to match the answer. So fraction 1.5 pi times 2 plus root 5. What do you guys get? I got 0.1127 blah 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 blah. Now, the 1 dp. What do I want? They didn't say. I'll just go 1 dp because the 1.5 is 1 dp. So therefore, yeah, dy dt is 0.1 centimeters per second. Guys, how's that? Nice and difficult, right? That's hard, right? Because it's hard because they didn't give you an expression for volume, right? They gave you a volume in terms of the integral, but when you differentiate the integral, you get the expression back, right? Guys, but that's how you do it. Hopefully that was nice. A nice question that combined curve sketching, it combined volumes, it combined rates of change. Yeah, if you like that, like the video, subscribe to the channel, tell your friends. Thank you very much. I'll see you in the next one.